You could be forgiven for thinking that Windows Azure Active Directory is the same as Windows Server Active Directory, only running in the cloud. The way to think of Active Directory from now on is as a continuum, from Windows Server Active Directory on the left-hand side through to Windows Azure Active Directory on the right-hand side, with each contributing their own set of relevant services. For example, Windows Server Active Directory offers 5 core services: Active Directory Domain Services, Active Directory Lightweight Directory Services, Active Directory Federation Services, Active Directory Certificate Services, and Active Directory Rights Management Services. Over on the right-hand side, today, there are just a couple of services: Windows Azure Active Directory, which offers services around the identity problem, and Windows Azure Access Control Service, which federates identities from external providers, like Google, Yahoo, Facebook, even your on-premises AD. But in the future, more services will be added. Windows Server Active Directory was designed to work on the corporate network, where the enterprise has full control over topology, and it exposes services for the management of identity, servers, workstations, security, network policy, and so on. And these are exposed through enterprise protocols like Kerberos, LDAP, DNS, AD replication, and so on. Today, Windows Azure Active Directory limits itself to one area: identity, and it exposes its services through protocols that work well in the world of Internet-connected cloud applications, such as a REST API and various Internet identity protocols. For this reason, you can't take an AD integrated application from the enterprise and install it in the cloud so you can connect it up to Windows Azure Active Directory. You have to build apps with the Windows Azure version of Active Directory in mind right from the outset. Many of you will have been using Windows Azure Active Directory for a couple of years already. That's because it's exactly the same directory service that's used to manage Office 365 for services such as Exchange Online, SharePoint Online, and Lync Online. Windows Azure AD was designed a few years ago from the ground up to support both Office 365 applications, Windows Azure Cloud applications, and Internet-connected applications. It's just that these features have only been released since July 2012 as a preview for developers. If you already have Office 365, you already have a Windows Azure Active Directory tenant. If not, you can get a free Windows Azure AD tenant at http://aka.ms/WAAD signup. So where does Windows Azure Active Directory, or WAAD, fit into the picture? Well, just as the enterprise starts to get a grip on the proliferation of digital identities and starts to solve the problems of too many usernames and passwords, cloud computing has started to refragment that story again. It's because the technologies and protocols that are used inside the corporate network to provide single sign-on and digital identity coherency are not very good at spanning the internet. The result is that often an application that gets moved to the cloud can no longer take advantage of internal identity systems, and the user is presented with a YAUP, a YAUP, or yet another username and password to remember. Traditional directories, like X500 or LDAP, expose a universe of hierarchies and relationships between the objects they contain. For example, certain users might be members of a group or a role. A user may have a manager, who has a manager, who has a manager, and so on. This so-called graph of the directory's content can be queried and returned to applications that require that kind of information. For example, to find a skip manager to approve your expenses when your immediate manager is on holiday. Windows Azure Active Directory is no different. It exposes the graph of relationships in this way with a REST API called the Directory Graph API. Azure Active Directory is a directory service that lives in the Windows Azure cloud. It's a highly scalable, distributed service that runs across many servers in Microsoft data centers around the world. The service exposes interfaces, such as the Directory Graph API we just mentioned, and authentication endpoints for OAuth 2, the SAML protocol, WS Federation, and more in the future. Now that's the service, but the service contains the data which is owned by each customer who has a tenant. There are lots of tenants inside the service. The tenants have names like mydirectory.onmicrosoft.com, but they can be configured to names like mydirectory.com. Each customer, though, looks after the data in their particular tenant. There's a portal to manage users, groups, domains, services, and so on. For the customer to configure an application, they create a service principal in their tenant. This is just an object that describes a service, their application. A couple of important things it contains are an identifier, known as an app principal ID, and a secret. The app is set up with a link to the service principal. It might also have a database that contains profile information such as the user's expense history. No usernames or password is stored here though, only application data. The Azure AD, in this case mydir.onmicrosoft.com, holds the user's ID and password. It exposes the authentication and graph API endpoints. When a user wants to use the application, they connect to the URL. The app redirects their browser to the authentication endpoint. That's when the Azure AD login page pops up. They enter their credentials, and then a security token is created by Azure AD, which contains, among other things, their name identifier, 123 in this case. The token is digitally signed, so there can be no doubt it was issued by this directory tenant and couldn't have been spoofed. The token is returned to the app, which validates the signature. In this case, the app then consults the profile database to find a match of the ID in the token, 123. When it finds it, it can retrieve the profile information for that user. At no time did the app see or need knowledge of the user's password. It's not practical for the entire content of the directory tenant to be returned in the token. This is where the application can use the Graph API. It can either access the directory using the secret, or, depending on the protocol, it can use delegated access, where it accesses the directory in the security context of the user. Say the app needs information about the user's manager. The details of the user's manager can then be returned, and this data could be used to, for example, complete an expense report. This scheme will work for applications deployed to the Windows Azure Cloud, to other cloud operators' environments, to your own on-premises applications, and for your Office 365 subscriptions, giving you web single sign-on across all of these platforms. But what if you have a substantial intranet infrastructure with file servers, print servers, IIS web servers, SQL servers, SharePoint servers, numerous AD integrated line of business and enterprise apps? Well, in that case, by deploying ADFS, Active Directory Federation Services, to your on-premises environment, you can use federation between your local AD and Windows Azure AD. That would give you Windows single sign-on to all of it. To keep the security principles in the two directories linked, there is a synchronization tool, DirSync, the same tool that's used to sync Office 365 to AD, to keep the two environments in sync with each other. When you use it in concert with federation, it means passwords are managed and checked by your on-premises AD. This is great because it means when a user leaves your organization, by simply disabling or deleting their on-premise AD account, they are automatically locked out of everything. This is a much superior solution to having apps each with their own username and password. A user might get time to use an internet-connected application before their account in it is deprovisioned and do untold business damage to the organization. If you're a developer using Visual Studio 2012, you can implement the protocols yourself, but by far the easiest way is to use the libraries supplied by Microsoft. you'll want to install the Windows Identity Foundation 4.5 SDK, the WIF F4.5 SDK, and then the ASP.NET Fall update for Visual Studio. This massively simplifies the process of making an application Azure AD aware. The context menu shows a new option, Enable Windows Azure Authentication. You're just prompted for the administrator credentials of your Windows Azure AD tenant, and from that point on, the creation of the service principal and the configuration of WIF in your application is done for you. You can even use the Publish item in the context menu to push your web app to a Windows Azure website, and the tool will update the configuration to work in the cloud for you. If you want to understand more, there are samples and instructions at activedirectory.windowsazure.com/develop. If you are new to Windows Azure, you may find it useful to sign up for a free 90-day trial subscription. And also, download the latest Windows Azure training kit, which has labs you can try for yourself.